All right, so last week of new material, we are going with perimeter and circumference for this first section of geometry. All right, so we want to find the perimeter or the circumference for each of the following, round to the nearest tenth if necessary. We can also always keep things in fraction form as long as it is simplified. The most basic definition to perimeter is the distance around the outside of an object. So when you're adding for perimeter, and it's going to get especially important when we are doing the later or more complicated ones, you want to make sure you're only adding outside sides and that you get every outside side. So perimeter, so here we have 1, 2, 3, 4, 5 sides, which means when I write my formula, which I have to in order to show your work, you have to write your formula, okay? Perimeter equals 1, 2, 3, 4, 5 sides. So we're going to have A plus B plus C plus D plus E. You must have this step. Our second step is going to be to plug in all of those outside sides, which I just highlighted. And we have 6, and we have 1, and we have 5, and we have 3, and we have 2. Now, the only trick to this is you really want to come up with a system that works for you. So I pick a side, I kind of mark it, and then I work clockwise around it. So I would rewrite this P equals 2 plus 6 plus 1 plus 5 plus 3. And then I'm going to add them. So I'm going to get 2 plus 6 is 8, plus 1 is 9, plus 5 is 14, plus 3 is 17. So it's 17, and I was working in inches, which means that my unit is still inches. Units for perimeter and circumference is just your inches, your centimeters, your meters, your feet. You want to make sure that all of those match before you start. If you have mismatching units, you're going to use what we did 2 weeks ago with unit conversions in order to get them all converted to the same unit. All right, for number 2, we have 3 sides. So we are going to have, and it's also a triangle, which is one of my formulas on the sheet. So I am going to have P is equal to A plus B plus C, because 3 sides, 3 lengths. So I'm going to plug them in. And I have 3.5 plus 3.5 plus 3.5. Notice I started at 1 and I went around. Since they're all the same, this is called an equilateral triangle. Which means all 3 sides are equal or congruent. You might see the word congruent. Congruent and equality are the same thing. Okay, so now I have mixed numbers, which I don't really like to use. So I'm going to turn them into improper fractions. So that's 7 over 2 plus 7 over 2 plus 7 over 2. I love this because they have like denominators. If you remember from our fraction section, our bottoms are the same. So we are going to just simply add the tops. So 7 plus 7 plus 7 gives me 21, or 7 times 3. And I keep the bottom as is, which is a 2. So our perimeter can either be written as 21 over 2 yards, or if I want to divide it out, I can, but I do not have to. This answer is okay. If I do, it's going to be 10.5 yards. And I'm done. All right, for number 3, we're finding the perimeter of a rectangle. And that means I can do one of 2 things. I can add up all the sides, or I can use this formula 2L plus 2W. Now, it really doesn't matter which one you make length and which one you make width. You'll get the same answer using either. But you want to make sure, you're just consistent with what you do for you. Now, with a rectangle, my rule is that if I have the top as 2.5, I also can say that the bottom's 2.5. And if I have the right that's 0.5, I can also say that the left is 0.5. That works whether I have the right or the left. I can jump it side to side. I can jump the top or bottom to either place as well. So 2 ways you can do this one. I'll show you both ways. We have 2L plus 2W or A plus B plus C plus D because, again, we have 4 sides. Okay, so if I make this 2L plus 2W, I just have to plug in my length or my width. So I'm calling 2.5 my length, which makes my 0.5 my width. So plus 2 times 0.5. Now, this requires order of operations. I have to multiply before I add. So 2 times 2.5 is 5, plus 2 times 0.5, or 2 times a half, is 1 whole. So the perimeter for this one is 5 plus 1, which is 6, and I am working in meters. Now, you see that if I start here at what I labeled my length, 2.5, and I work around clockwise, for this, I get 2.5 plus 0.5 plus 2.5 plus 0.5. And I will get 2.5 plus 0.5 is 3, plus 2.5 is 5.5, plus 0.5 is 6. So I get 6 altogether. And again, I'm working in meters. So you see that regardless of how I do it, I get the same answer. Now, number 4 says that I have, I'm looking for my circumference. And I know it's circumference because the perimeter of a circle is called the circumference. Okay. 2 terms that I need to know for a circle. If through that center point I have only half of it, that's called my radius. If I have all the way through, that is called my diameter. The reason this is important is because I have 2 different formulas to pick from here. I can either use circumference equals 2 times pi times r, or 2 pi r. They can drop the dots. Or I have circumference equals pi d, or pi times d. Now, in this case, right here, I have the diameter because it goes all the way across, which means my easier formula to plug in for would be this one, and I would get C equals, sorry, I probably shouldn't use yellow. I have C equals pi times 7, which equals 7 pi. Now, pi is just a number. It's a very famous number. There's a whole day dedicated to it in March, 3.14, March 14th. If you know that, your calculator will not have a pi button. You have to know that pi is equal to 3.14. Okay, so it's just a number, it's just a fancy number, but you can leave your answer like this. This is called in terms of pi, okay? And you can leave your answer like that. Or you can substitute that in, and I know I'm kind of running out of space here, okay? You can say this is the same as saying C equals 7 times 3.14. And then you can do that calculation. I don't have my calculator right in front of me. I'm going to pause and grab it. All right, I'm back. 7 times 3.14 is 21.98. It told me to round to the nearest tenth, which means that I need to take that 8 and see what it does to that 9. The 8 bumps the 9 to a 10, but we can't put a 10 there, so it actually bumps the 1 to a 2. So my answer for this ends up being 22.0. Now, if I'm just going to come out for a second because I want to do it my other way. Okay, what if I used the radius instead? Well, I couldn't go straight to the radius because I was given the diameter here. So if the diameter is 7, the radius is 7 divided by 2 because the radius is half of the diameter. Okay, or the diameter is 2 times the radius. This is all very important for this one, so I highly suggest all these little notes that I've written down. If you weren't copying them down, rewind, pause, go back, write them down. Make sure you know where I'm getting things from, okay? And if not, bring those questions with you on Tuesday. So when you do the radius, or when you find the radius, you're going to do 7 divided by 2, because again, I'm taking this whole thing and I'm cutting it in half, right? So 7 divided by 2 is 3.5. So what I'm going to do down here, I'm going to plug that in, and I get 2 times pi times 3.5. And again, remember that pi is just a number. So this is pi, and then I can multiply the 2 and the 3.5. And the 2 and the 3.5 give me 7. And again, I have 7 pi. So you notice you get the same answer either way. Similarly, I can take 7 and times it by 3.14 to get my decimal answer, which would ultimately be C equals 22.0. All right, so we get another chance at a circle. So if the last one kind of boggled you for a little bit or for a hot second, you get another chance at this one. So right here, we have the radius. The radius is 10. So we'll practice doing it both ways. C equals 2 pi r and C equals pi d. Now, if I have the radius, I'm going to plug into that one because there's an r there. We can substitute the r out and put the 10 in. Just like if I were to have a substitute teacher for the night, they would teach you the same way as well, maybe not the same way I did, but they would teach you the same material that I was planning on teaching. Okay, now if I want to get from my radius to my diameter, I'm going to take 10 and I'm going to multiply it by 2. So the diameter is 20, and I can plug that into this one. So let's jump back to the first formula. If I plug in 10, I get C equals 2 pi 10. So once I have that, again, that pi just kind of sits in the middle. I know it feels like it's in your way, but there's a mathematical property called the associative property or the commutative property, depending on how you look at this, that allows you to do things in whatever order you want when it revolves around multiplication. So I am going to grab this 2 and this 10, and I'm going to multiply them, and I'm going to get 20 pi. Now I'm done, okay? I'm not going to take it to my decimal right now. I'm going to make sure I check the other one and I get the same thing. So over here on the right, I'm going to get C equals, or circumference equals, pi times d. Well, d is 20 because that's what I found. So when I do this, it's just an etiquette thing. You don't want to leave it as pi 20. You want to write it as 20 pi. Okay, think like you have 20 pies. Now, when I do this, if I wanted to, I could take either of these and I could multiply the 20 by 3.14. And when I do that, I'm going to get, 62.8. And that is rounded to the nearest tenth. So I am done. All right, let's look at number 6. We have a square with side of 5 yards. Now, if they don't give us a picture, we want to draw one for ourselves. That is step 1. No picture, you draw one for yourself. Now a square has all 4 sides equal. I can mark them with these tick marks that tell me, those tick marks tell me I have 4 equal sides. And I know that 1 is 5. Those tick marks allow me to only write the 5 in one place. Okay, if you want to write it all the way around, you can. But with those tick marks, you only have to mark it in the one place, and then you can assume anywhere else you see that one tick mark, it is also equal to 5. So now I have 2 ways of doing this. I can do P equals, that side that they gave me, plus the same side, plus the third, plus the fourth. And the reason why it's not A, B, C, D, you could write it A, B, C, D, but ultimately all of them are the same. So we can just use the same letter over and over. Or we can do P equals 4 times S, because we're going to take 4 times whatever side length they're given, because I have 4 sides. So I'm either going to have 5 plus 5 plus 5 plus 5, which gives me 20, and we're in yards. Or I can do 4 times 5, which is also 20, and again in yards, and hopefully they match, because that is the whole point. I'm working within the same problem. I'm just showing you 2 ways. Do you have to do any of these like we've done 2 ways? Absolutely not. It's a good way to check your work, number 1, and number 2, it's just a good way to practice different ways of doing it. Now, an isosceles triangle, we talked about what an equilateral triangle is. An isosceles triangle is a side with 2 equal sides, okay? So if we draw this, we can draw a triangle that looks, for our brain's sake, to not trick ourselves, triangle that looks like it has 2 sides that are equal, and they are equal to 7.5. Okay, 2 equal sides equal to 7.5. The third side is equal to 4. So now that we have our picture, we can do it the same way we did number 2. A plus B plus C, which is 7.5 plus 7.5 plus 4. Does it matter where I start or what's my A? Absolutely not. Just make sure you get all 3. 7.5 plus 7.5 is 15, plus 4 is 19, and we did not have a unit. Notice they didn't give me inches, centimeters. What is it? So we just write units after it if they don't give us one. Whoop. Okay. My page gets jumpy sometimes. Number 8, final one, we have a rectangle with a width of 8 and a length of 4.5. I usually just, again, length and width, it doesn't matter which way you orient this. However, what does matter is that when I draw my triangles the same way, I'll always draw one like this where it's wider than it is long, it's left to right longer than it is up and down. So I usually just try to, for my sake, because it doesn't matter, put my numbers where it looks correct. However, they could give you a picture that looks like that, and it makes no sense at all, but they will always put the disclaimer that the figure is not drawn to scale. So basically, they are not responsible for tricking you into thinking something about the problem. So you want to always ignore the assumptions you want to make because of how a picture looks. So I'm going to write that the width is 8 there, and the length is 4.5 there. If I have it on top, I can have it on bottom. If I have it on right, I can put it to the left. Okay, again, you have those 2 different ways of doing it. I'm going to do 2L plus 2W. So I get 2 times my length, which is 4.5, plus 2 times my width, which is 8. Notice that one comes in there, that one comes in there, and I get 9, because 2 times 4.5 is 9, plus 16, 2 times 8, and when I add 9 plus 16, I get 25, and I am working in centimeters. Try some on your own. Make sure you have a good understanding for this, because the culmination of this week will be your collected assignment, which has a little bit of everything on it, and I will see you soon. If you look at the reference sheet that I posted, okay, perimeter is going to be this first column, okay, and we have a square, a rectangle, a triangle, and a circle. Realistically, we could do any polygon, we just have to add up all those sides. So instead of like for a triangle it being P equals A plus B plus C, which represents 3 sides, it would be P plus A plus B plus C plus D plus E plus F plus however many sides there are. If there's 8 sides, you need to have 8 numbers that you're adding up. If there's 3 sides, you need to have 3 numbers that you're adding up. But the important piece is that you notice, what are the differences here between square, rectangle, triangle, circle, and then cube, rectangular prism, cone, sphere, and cylinder. The ones that I just highlighted in blue, square, rectangle, triangle, and circle, are representative of 2-dimensional or 2D shapes, flat shapes. Whereas all the ones that I highlighted in yellow, cube, rectangular prism, cone, sphere, and cylinder, are all 3-dimensional or 3D objects. And you should be thinking about this because for the 3D objects, we're going to be talking about volume. You could also talk about surface area, but we will not be for the purposes of this class. And for the blue ones, for the 2D shapes, we're going to be talking about their perimeter and their area. Now, we use the perimeter and the area, especially the area, to help us with the volume, but they're related, but they're not the same. So if we look at this, the only thing to note is that why is it perimeter and circumference? Circumference is the perimeter of any circle. That's what we call it. It has a special name.